Hello, my name is Robert Smitty Smith, and I'll be your instructor in the shop here in 141 in Engineering Tower. And this little video here, I'm going to discuss basic hand tools and identify them so that the new people to shop work will have an idea of what we're talking about when we send you after a specific tool, and make it clear what some of these are used for and what they are not used for. So first of all, if you go back to absolute basics, probably the first tool that a caveman had was a club to beat something with. So we'll start down here with hammers. And if you look at this small array of hammer, you'll see that we have a small and a medium size of this one particular style. This is called a ball peen hammer. And this is your basic shop hammer. Now most people think of a hammer, they think of this hammer here. This is a carpenter's hammer. It has a claw for extracting nails. That's why it's called a carpenter's hammer, or sometimes a framing hammer, or a claw hammer is its most common term. These two are non-marring hammers. This has plastic tip on one end, rubber tip on another. This one's all plastic. This is for knocking things without denting them and marring them up. The ball peen hammer, you have a flat striking surface on one end and you have a ball on the other. Amazing how that works out. So maybe that's how it got its name, from that ball end, which is used to peen metal. Look up the word peen. You should know what peening is. Now, basic tools, hammers. And they are used to strike with. And one of the main things they strike is this tool right here. This is called a centering punch. It has a hardened, sharp tip. And when you have a line drawn and you want to drill a hole on a specific spot, you take this, you place the tip on your mark, you take a hammer and you moderately strike it like that. That will put a dimple into the metal, the plastic, the wood, whatever you're working with. That way, when you have a drill and you insert the drill, it can fit into that little dimple and not walk around. That gives you a lot more accuracy when you get to drilling holes. And that is a centering punch. There are other kind of punches, but we don't have them out here. This is the one you need to mainly be concerned with. This is a machinist square. It is for checking things to see if they are square with the surface, or for drawing. If you put this across something, you could mark a square line perpendicular to the long axis. And what you would mark it with, if it's a surface that doesn't lend itself to be written on, will be this tool here, which is known as a scribe. It has a 90-degree sharpened point on one end and a straight point on the other. So if you have a straight edge and you wanted to mark a straight line, you could use the 90, place it against the straight edge and pull, and it should scratch a straight line in the metal as a reference line for marking your layout projects. So you have those tools. Now, you'll also be using files. Small files, larger files for shaping and removing metal. This tool here is called a comb, a file comb. When the files become embedded with softer metal and material, they tend to clog up the cutting serrations, and you use this. This is nothing more than a wooden board with lots and lots of little wire embedded into it, and it works in one direction. You can go across the file and the wire will remove, just like combing out your hair, this will comb out the stuck particles on a file. So you use the small files for fine detail work, making sharp corners and holes and things like that. and on very small scale stuff, and use larger files for the larger things. Now, so that brings us over to drills, making holes. You need to use a drill. We will be using a drill press and electric hand drills. Electric hand drills have a lot more torque than their battery counterparts. You will also have access to drill sets. This is the drill set you'll have access to. This row is wire gauge size 1 through 60. These drill bits conform to a certain standard of wire gauges, and their decimal equivalent is marked just below them. Over on this side are letter drills. There's a certain standard for drills that are in letter sizes, A, B, C, D, E, F, G, etc. Then over here we have the fractional sizes. 1/2 inch is the largest, 1/16 is the smallest, and all the fractions down to 1/16, usually by 16ths. So there are 3 different standards, and you have all 3 of them here. Out of these 3, you should be able to make any diameter hole up to and including a 1/2 inch. These are specialty drills. These are called step drills. I'll hold it against my shirt here. You can see there are a series of increasing or decreasing steps as I go up. This is the tip. It has a regular drill bit point. It penetrates, and then it drills up to this one, and then it has a cutting edge here. These are most useful for drilling in plastics and very thin, soft sheet metal and that kind of thing, rather than this type of twist drill. This will not deform your thin sheet metal, and it gives you the ability to change sizes without having to change drills. This is a countersinking tool, and that way if you bore a hole in a piece of metal and the entrance and the exit part of that hole can be rough, you put this in your drill and you spin it and insert it, and it reams the edge of the hole and makes it nice and smooth. This tool right here is a hand reamer. It has a little swivel tip, so you can insert it in a hole, drag it around, and it will cut that little sharp edge that's left. This is called a tapered reamer. This is for enlarging a hole that's a little bit too small. You can't quite get your fastener to go through it, so you insert this hand reamer and then slowly twist it clockwise. The cutting flutes are designed to cut on the clockwise twist, and that will slightly enlarge the hole so your fastener can then go in. Now, you drill holes, and you may want to put threads in those holes. These are taps. These are what cut threads into a hole in a material. A hole has to be drilled of a very, very specific diameter. If the hole is too small, then this thing will bind up and not go in. Of course, if you make the hole too large, then the cutting edges can't touch the sides properly and can't cut the sides. We have charts that'll be on the wall that will tell you if you want a specific hole, for example, a 1032, then go get a certain drill bit, drill that hole. Then you take your drill, after you've removed your drill, you take a tap. This is a tap holder and turning handle. It has jaws that come together. The taps have square edges. You hold it in like this, crank it down, tighten it. Now this allows you to insert the nose into a hole, lubricate the cutting threads with lubricant, and you're able to turn it and cut threads in the material. We will show you more in detail how to do that. This is just to show you what the equipment is, this particular workshop. So that's taps, that's a tap handle. Okay, now, these are a certain class of hand tools. We're getting into another class of hand tools called drivers. These are all drivers. See the handles. That reamer is also a driver. A driver means it's used by the hand and driven by the hand exclusively. These are screw drivers. They're designed to turn screw fasteners. And if you look at the tip, you will see that it's a straight blade. So that's for a straight slotted screws. These have a cross tip point. Now that's known as a Phillips tip. The most common size is this size right here, is a number 2. That is what almost all the fasteners in the home and a lot in industry begin with the number 2. If you go smaller, that's a number 1. If you go smaller than that, that's a 0. If you go very, very small, like in electronics work, that would be a 0, 0, then 0, 0, 0. So to go smaller, you increase the number of zeros. If that's a number 2 and this is the next size up, logically, that's a number 3. And this even larger size is a number 4. So that's the way it works. The standard everyday size is a 2, and then if you go down, 1, a 0, a double 0, triple 0, etc., and then they can go up until very large sizes. This is another driver you will see in automotive applications quite a bit and in industry. If the camera can zoom in on it, it is a spline drive. It has a series of splines, and it's inserted into a fastener that has a female socket that has matching splines. The brand name is a torque drive. Now, I should talk a little bit about what makes a lot of tools confusing, why some people will call one tool one thing, same tool will have a completely different name, is that there's manufacturers' names and brands, and then there's the basic name of the tool. This is a driver. This is a family of drivers. This is an adjustable wrench. It is not a crescent wrench or a craftsman's wrench, that's a brand. Some people may ask you to bring them a crescent wrench. They're talking about a brand when they say that. So there are families of tools and generic terms for them that engineers should use the generic term rather than the brand name. If someone said, go get me a Pepsi, you know instantly they mean a Pepsi Cola. But the generic term would be, go get me a cola, please. If you say Pepsi, then you're being brand specific. Same way with tools. If you say go get me a pair of vice grips. That's these units right here. That's the brand. If you look right there, it'll say vice grips on them. What these are locking pliers. They have a mechanical locking mechanism that squeezes them shut and holds them shut. The brand is vice grips. And they held the patents on that, and it became almost common knowledge and an interchangeable term with locking pliers. The correct engineering term, locking pliers. All right. This wrench right here, this was one of the early wrenches in a slightly modified form. Today's name for this wrench is a plumber's pipe wrench. It has serrated teeth on the jaws. And the people that use this are people that work with pipe and have to thread pipe together. The serrated jaws, as the thing is rotated, grab the outside of the pipe and rotate it. Now, if you didn't have the serrated jaws, if you had flat jaws, you would have what's known as a Stilson wrench. Sometimes these are incorrectly called Stilson wrenches or monkey wrenches. They are neither. They are pipe wrenches if they have serrated jaws. If they have no serrated jaws, they are an adjustable wrench. This is an adjustable wrench. The angle is just changed from perpendicular to the long axis to angled off the long axis. That's an adjustable wrench. That's an adjustable wrench. And beginners tend to love adjustable wrenches because you have many sizes in one. So you don't have to go back and get a specific size. However, these are for moderate torque and low torque applications. If you really put a lot of torque on a fastener with these, they will tend to damage the fastener, round off, the jaws will spread. You should use a correct size open-end wrench. This is an open-end wrench. Show you how this is just some out of my set. This is 1 3/4 inches across. Look at this little one. This is a 5mm adjustable wrench. But these are all wrenches. And that's an open-end wrench. That's an open-end wrench, sometimes called a double open-end wrench because it has one set of jaws on one end, another set of jaws on the other. These happen to be the same size, but look at the angle relative to the long axis. They're two different angles. This aids in turning fasteners that are in close quarters. Same way with this one. This is a double open-ended wrench and it has different offsets on the long axis. Probably the most common wrench is a combination of open-end, box-end, closed-loop, box-end, because you have the best of both worlds. Open-end are for up to moderate size torque because the engagement is on two flanks only. If you really put a lot of torque on tightening a fastener, you can round off the edges. But when you have a high torque application, you want to go to a box-end wrench because you have engagement all the way around. This is a 12-point box end. This is a double box end, and notice the offset. Wrenches can come in different offsets, and as you can see, this is the same size as this wrench, but it's a double box end, has offsets, so it can reach into areas in equipment, in machinery, that maybe this offset angle couldn't reach into. Here's a larger size, again, 12-point. They also make these in 6-point. The 6-point will grab a 6-sided fastener with a better grip than a 12-point. This is we'll get over here. These are some specialties. This is a double box end that's been bent. It's designed to operate by reaching around an obstacle and get on a fastener and turn it. One of the great advantages of the 12-point is because the gripping surfaces are so close together, you can reorientate the wrench with only a few degrees of difference. So you can re-grab the fastener, turn it slightly, re-grab it, turn it when you can't get a full swing. If you can get a full swing, a 6-point is superior. Now this one is a hybrid between a full box end and an open end. As you notice, they've used part of the box end to reach further around than this one will. But the reason for that cutout, this is also called a fitting wrench for hydraulic fittings. This can reach over a hydraulic line, can pass through that opening, and then the wrench can slide down on a nut on a hydraulic pump and tighten the fitting, and it grips better than an open-end fastener of the same size. So that is the basic wrench family there. Now let's move up into a very special area of wrenches. Here we have, these are called sockets. These are handles that fit sockets. If the handle has a mechanism for rotation, it is called a ratchet, because inside is a gear and a spring-loaded pawl that will go in and catch. Hear the clicks? As it goes around, it will go one click and stop. Go one click and stop. So you can turn it, swing it back, apply torque, bring it until the handle hits an obstruction, and then swing it back. You don't have to take it off, reorientate it, put it back on, like you would have to do with this. This has no ratcheting mechanism, but it's capable of transmitting a lot more torque than the ratchet type mechanism, which can break. This is called, you might call this a plain handle. It's in the industry known as a pull handle. You put a socket on it and pull the handle, and it will withstand a lot of torque. So the combination together is a socket and a handle, which creates a socket wrench. This is known generically as a ratcheting socket wrench. If it did not ratchet, if it was on the non-ratcheting part, it would just be a socket wrench. And within this family, you have sub-denominations. You can have sockets of the same fastener size, but you see the size of that drive, and you see the size of that drive, you see the size of that drive. They are discretely known as by their drives. That is the smallest, which is a 1/4 inch drive. Notice the handle is shorter. It's capable of controlling less torque, or handling less torque. This is a 3/8. These are in fractions. That's a 3/8 drive. Uses a larger, stronger mechanism. This is a 1/2 inch drive, and this is generally as large as you need for automotive use. When you go to trucks, bulldozers, industrial machinery, you'll go to 3/4 inch drive, 1 inch drive, and even up to, I've seen as large as 1.5 inch drives, but that's for very, very massive parts. For automotive use, 1/2 inch drive is generally sufficient for everything on an automobile and smaller. This is an extension which will go on one of the drives to extend the reach of the socket, so it can get into a deeper area than it normally could if it was mounted here. Also notice 6-point drive for maximum torque. 12-point, you have more choices for getting it on, but the smaller teeth will hold less torque. For maximum torque, use a 6-point drive. Here's a specialty item. As mechanical engineers, you should want to know this. The common 99% of all sockets you'll see are 12-point or 6-point. However, there's an intermediate. Let the camera move in on that. This is an 8-point. And if you notice here, it's for square nuts. There's still some square nuts out there on farm equipment and in industrial equipment. Square nuts are very economical to build compared to hex nuts. So they are a specialty tool now because they're relatively uncommon, but they are 8-point socket sets for square nuts if you have any of them. The last wrench we will look at is a torque wrench. You've probably heard this term. These come in many guises. This is the simplest and most reliable of all torque wrenches. This is known as a beam type. You put a socket on it. Socket goes down on a fastener. You see here you have a scale. You have a scale that goes one way. You have a scale that goes the other way. Here it's calibrated in Newton meters. Here it's calibrated in foot-pounds of torque. Notice the handle rocks. It has a pivoting pin in the center. Now the way this works is that steel is a very, very good spring material. So as you generate torque tightening a fastener, as you pull on this handle, and you never want to let this handle slam against the side. As you're pulling at the torque, you want it to float. That way the force you're transmitting in rotation goes through this point here, and that's a known distance, and that makes the reading absolutely valid. So I can even force this thing as it moves, as it generates. This stays still, the larger beam bends, and the more it deflects and bends, the more torque you're generating. Now the proper way to tighten a fastener with a torque wrench is that you bring it, you have to know ahead of time what the torque limit should be on a particular fastener in a particular material, and if the thread should be lubricated and with what. So you have lubricated threads usually, like on an engine, and then you start tightening, and as you feel the torque try to rise, you don't want to pull and stop and then start and stop and start and stop. Once you feel the torque starts rising, if I want to go to 35 foot-pounds, I pull, and I keep pulling until the indicator goes up to 35, and then I hold it on 35 for a couple of seconds to make sure it's stabilized, and then I release the pressure. Then I have created a proper torque. If I pull it up to 20 and stop, and sometimes you have to because the handle will hit, then you have to be careful of that because there's a starting torque involved. You have to break the stiction of the fastener if it's not moving. That's why once you start torquing, you want to try to bring it up in one smooth move if possible. And that's a torque wrench. They're very simple to use and they're invaluable in industry. So now we're up to our last family of hand tools. Pliers. All of these you see here are pliers. They can have different names, common names, but basically underneath these are all pliers. They have a pivoting point and they have handles that are hand operated. These are diagonal cutter pliers because the jaws are ground on a diagonal. I'll get a little piece of material, and they're for cutting metal, wire, cable. Closer you come in, the more torque you have crushing down. When you're out on the tip, it takes more torque here to do the same job. This is one pair. This is another pair, just slightly different shape, does the same thing. Here's a smaller pair that you would use for cutting wires in an electronic project. And another thing about using hand tools, you want to scale the tool for the job at hand. If you were trying to cut through a piece of metal this thick, you wouldn't want to use those little tiny pliers. You'd want to come up here with the biggest ones you had. Try to scale the hand tools to the size of the work you're doing. These are called linesman pliers, diagonal cutting pliers, linesman pliers. These are just everyday, what most people think of as pliers. These are actually a slip joint plier. Notice the jaws don't quite close. You slip it over here on this side, and for grabbing larger objects. You slip it over for the other side, now they close down cleanly. Also at the bottom, you see the jaws overlap like incisor teeth, and you could actually cut through wire if you had to with the bottom of the jaws here. It won't cut as well as these specialty pliers designed to cut, but will cut if these are the only pliers you have. These are cutting pliers also. These are not for cutting bolts. They're not for cutting anything but what these are designed for. These are wire cutters. They are designed, that's why they have the curved head here, to put a wire cable in there and to slice through copper wire. And if I ever see anyone cutting anything but wire with those, they will be the devil to pay because they will destroy them and they're very expensive. These are duckbill pliers because they have a slightly extra wide jaws. Quack, quack, so I could get their name, duckbill pliers. These are specialty pliers. Notice the noses. They have little male shafts that stick out. These are called snap ring pliers. And snap rings are circular rings, much like the drawing on the handle, that have little eyelets in the end. And these little tips go in those eyelets, and as you squeeze down on them, the metal clip gets smaller and it comes out of its groove. These are for removing snap rings. These are some specialty pliers for removing spark plugs, spark plug wiring. They reach around the insulation and grab the insulation and twist it. These are some specialty pliers that have special jaws for installing and removing piston rings on pistons. These are some specialty pliers for hose clamps on radiator hoses. They have, let's see if I can open these up. They have rotating pads, and the pads are notched to grab rings that have little ends like this. These grab the ends and squeeze, and the rings release off the radiator hoses. These are a specialty pair for, again, metal clips. These are for the type of clips that go around the shaft, and you want to expand them with these pliers so they'll come off a shaft like that. No holes in the end, just the end of the rings. Okay, so those were some specialty. These, notice the long, skinny nose, Needlenose pliers. These are a shorter version of Needlenose pliers, and they have built-in cutters, so if you could cut wire with them. These are some extra long needle nose pliers, straight, no cutters. These are extra long needle nose pliers with a bent shank for reaching in. These are the same thing, except the ends have been bent 90 degrees. And here's some extra long ones, and they have serrated jaws in a circular shape for grabbing round things and twisting them. Now, I've saved these for last. There's been more confusion on this type of plier than any other. They've been called monkey wrenches. They're not monkey wrenches. They've been called Stilson wrenches. They're not Stilson wrenches. They've been called channel lock. Again, brand specific. These are slip joint pliers, pure and simple. They have a joint. You can move them to a certain place and you can slip them back and forth to control how far the jaws open and close. That's a slip joint plier. Same thing, smaller version. See the groove? Move it, find the release groove, and you can adjust it for different size fasteners. Slip joint pliers. And one more thing we want to talk about when it comes to drills is you got to hold the drill bits in the drills, and that is the job of this device here on the nose. It's called a chuck. This is the most common type of chuck today. It's called a keyless chuck. And basically, if you turn it clockwise, which is a normal way of tightening, the internal jaws close down, grab the drill bit, and you just give it a good clockwise to lock it down. You drill, and then when you want to release it, you grab the silver part with one hand, the black part with the other, and you twist counterclockwise to release the drill bit. Now, if this is a keyless chuck, what is a keyed chuck? And that's this little darling right here, and you will still see these in a lot of applications. As I turn this ring, just like the ring here, you can see the three jaws close down. And as I turn it back, you see them open up. You insert the drill in there, turn it down, and close it. Except with this one, you can't tighten it enough by hand because you don't have an internal mechanism designed to cam latch down. With this one, you have to have something called a key. See the holes? See the round nose? Round nose goes in the hole. Then the teeth on the key rotate clockwise again to tighten. As you rotate clockwise, it will bring the jaws down until finally you tighten it down, you drill, and then when you want to release it, you reinsert the key, and then you turn counterclockwise to open the jaws. This is a keyed chuck. And guess what? Lose the key, the drill and the chuck are no good. Do not lose the key. That's why this one is on a wire and it hangs up right next to where the drill is all the time. So, do not lose the key. You keep the key with the drill at all times. And that's it. And that, students, are your basic hand tools you will see in most shops. I've identified them. Use the correct ones for the correct applications. So go do your projects.